Hello students, so in this video we're going to cover some background information and then some examples from section 6.3 on confidence intervals for proportions. Okay, so let's go over some background information that will help you better understand what we're going to do in this section. So the population proportion, okay, which is represented by the symbol P, okay, lowercase letter p, measures the proportion or percent of a population that have a certain characteristic or who hold a certain belief. So for example, proportions are often used to report the percent of registered voters who will support a candidate for a political office or how they will vote on a proposition. Okay, likewise, we can use proportions to report the percent of products that have a certain defect. Okay, so these are just a few of many different examples where we use proportions. So the percent or proportion in a sample that have a certain characteristic or who hold a certain belief is represented with the symbol p hat. Okay, so if we're talking about a sample if we're talking about a proportion from a sample, okay, we use the symbol p hat, just got a little caret on top of it. But if we're talking about the proportion of an entire population, right, we use the symbol lowercase letter p. Okay, so the symbol p hat is often called the sample proportion, all right, and is given by this formula here. So p hat equal to x divided by n, all right, where x is the number of successes in the sample. Okay, what I mean by that is, right, how many in the sample, right, have the characteristic in question, whatever that characteristic is, or how many in the sample hold the belief in question. Okay, so x is the number of successes in the sample, and then n is the sample size. Okay, so remember proportions represent parts of a whole, so proportions will always be between 0 and 1 when expressed as a decimal, right, or between 0% and 100% when expressed as a percent. Okay, and you saw a similar thing with probabilities, right? So proportions and probabilities are very similar, okay? But remember, proportions represent parts of a whole, right? Probabilities express the likelihood of an event. Okay, but in any case, proportions are always between 0 and 1, right? Or 0% and 100%. Right, so you will never see proportions that are negative. Okay, likewise, proportions cannot be larger than 1, okay, in statistics. Okay, so let's go to look at our first example, and this is problem 1 from the homework in section 6.3. Okay, and it says, use the given confidence interval to find the margin of error and the sample proportion. Okay, so this is understood to be a confidence interval for a population proportion. Okay, so the interval is reported using what's called interval notation. So this is interval notation, right? You got the lower limit of the confidence interval with a comma, and then followed by the upper limit of the confidence interval. Okay, and they're both enclosed in parentheses. So this is called interval notation. All right, you saw it before in the previous section. Okay, so our confidence interval, the given confidence interval, the 0.736, comma 0.762. Right, so remember, this is a confidence interval for a proportion. Okay, so the lower and upper limits of the confidence interval, okay, for a proportion, right, will also be between 0 and 1. Okay. Okay, so to find the margin of error, right, from this confidence interval, right, we're going to take the positive difference between the upper and lower limits. Okay, and then divide by 2. So E is equal to 0.762 minus 0.736, and then divide that difference by 2. So 0.762 minus 0.736. Okay, we get a difference of 0.00 or 0.026, 0.026. All right, we're still going to divide that by 2 to get the margin of error. Okay, so divided by 2. Okay, so our margin of error is 0.013. Okay, and it says type in integer or decimal, right? So our answer is obviously a decimal, so it should be 0.013, right? It should be the exact decimal that we get. Okay, remember margin of errors are always positive. So if you're getting a negative margin of error, right, it means you're subtracting the confidence interval limits in the wrong order, right? So you start with the upper limit, subtract from it the lower limit, and then divide the difference by 2. Okay, so now it's asking for the sample proportion p hat. Remember, any confidence interval that you do, right, is always based on sample data. Okay, whether it's a confidence interval for a proportion, a mean, or a standard deviation, right? There's always sample data that we collect from the population, right, to obtain our confidence intervals. In this case, we're looking for the proportion of our sample. Okay, and we can obtain that from our interval, okay, by adding together the upper and lower limits of our interval, okay, and then dividing the sum by 2. Okay, remember we did this in the previous section. Okay, when we talked about confidence intervals for the population mean. Okay, so it's a similar concept, except that we're finding the sample proportion rather than the sample mean. Okay, so on our calculators, I'm going to do 0.762 plus 0.736. Let's get that total there. So it's 1.498. And we're going to divide that by 2. All right, so our sample proportion is 0.749. Okay, we've correctly completed question 1. So before we move on to the next example, right? If so, we can represent this confidence interval, okay, visually, okay, as like a number line, a section of a number line. Okay, so the lower limit is here, the upper limit is here. Okay, so the sample proportion for this interval is in the middle of the interval, right? So it's the midpoint of the interval. Okay, so our sample proportion is 0.749. Right, it's right here in the middle of the interval, right halfway between the lower limit and upper limit. Okay, so likewise, the margin of error, right, is half the distance between the lower limit and upper limit. Okay, so from the lower limit to the sample proportion, right, is the margin of error. Likewise, from the sample proportion to the upper limit is also the margin of error. Okay, another way you can think of this is, right, when you take the sample proportion from your sample and subtract the margin of error, you get the lower limit. Likewise, if you add the margin of error, you get the upper limit. Okay, so example 2 or problem 2 in the homework is much like the one we just did, so I'm going to skip it. And we're going to begin problem number 3, which says, in a survey of 2,459 adults in a recent year, it says 1,335 say they have made a New Year's resolution. Okay, so what we're going to do is construct a 90% and 95% confidence interval for the population proportion. All right, and then we're going to interpret the results and then compare the widths of the confidence intervals. Okay, so we are going to do this in StatCrunch. Okay, so I've created a brief summary of what is given to us in the problem, okay, and what the problem is asking. Okay, so again, according to the problem, our sample size, right, was 2,459. Okay, so 2,459 people were asked whether they made a New Year's resolution. Okay, and their response to the question would either be a yes or a no. Okay, so again, according to the problem, right, 1,335 of those people said yes, they did make a New Year's resolution. So x equal 1,335 is the number of successes in our sample. Okay, and the problem is asking for a 90% and 95% confidence interval for the proportion of all adults who made a New Year's resolution in the recent year. Okay, so we're going to use StatCrunch to obtain the confidence intervals. So in other words, we're not going to reference any of the formulas from the book to get the confidence interval. Okay, but it is worth mentioning that just like in the previous section, right, there are certain assumptions that our data set must meet, okay, before we get the desired confidence interval. Okay, so and one of those assumptions is that the sampling distribution of the sample proportion, right, is approximately normal. Okay, So the sample proportion p hat is approximately normal, right, when there are at least 5 successes in our sample. So this notation means, right, at least 5 successes. Okay, and likewise, there are at least 5 failures in our sample. So we're not going to spend any time verifying the requirements, but just know that if the requirements are not met, if the data do not satisfy the requirements, then the method that we use to obtain the confidence interval, right, will not work or will not be accurate. Okay, so again, this notation means that there are at least 5 successes, and then this notation means that there are at least 5 failures. So if we look at the summary of our data set, we see that there are 1,335 successes in our sample. So in other words, 1,335 people said they made a New Year's resolution in a recent year. Okay, so there are definitely more than 5 successes. Okay, but what about the number of failures? Right. Well, if this many people in our sample are considered successes, right, then the number of failures is equal to the sample size minus the number of successes. Okay, and you can do that on your calculator, and there are definitely more than 5 failures in our sample. Okay, so our sample data, right, satisfies the requirements. All right, so we can go right ahead to StatCrunch to get the confidence interval. Okay, so let's go to the stat menu. And we're going to select proportion stats. And since we only have one sample, we're going to select one sample. All right, since we don't have the actual data, we have a summary of the data. We're going to select with summary. Okay, and the number of successes was 1,335. And the number of observations, which is basically your sample size, is 2,459. Okay, all right, and we're doing a confidence interval. Okay, we want a 90% confidence interval first, so we're going to replace the 0.95 with 0.90. Okay. And what it asks for the method, it's the standard method for obtaining a confidence interval for proportion, so you're going to leave that option selected. And then you can check the box to see a plot of your confidence interval. Okay, that's optional. Okay, so this tells you that you're doing a confidence interval for a proportion. Okay, this is the number of successes in your sample size. It also tells you the sample proportion, right? So if you want to know how they get that number, right, it's the number of successes divided by your sample size. Okay, that's that number here. Okay, this is your standard error. Okay, not to be confused with the margin of error. Okay. What we want are the lower and upper limits of our interval, which are here. Okay, so we're going to round these to 3 decimal places. Okay, so the lower limit is 0.526. Okay, and then the upper limit is 0.559. All right, so let's go back and do a 95% confidence interval. So what you can do is you can click Options, select Edit, all right, and you can change the confidence level if necessary. So it's going to go from 0.90 to 0.95. Okay, with everything else left alone. Okay, the sample proportion is still the same. Okay, the standard error might have changed, all right, because we changed the confidence level. All right, and it definitely changes the lower and upper limits, so to 3 decimal places. All right, for the 95% interval, right, the lower limit is 0.523. Okay, what you'll notice is a little lower than the lower limit of the previous interval. Okay, and then the upper limit is now 0.5625, so that 2 there at the end is going to get rounded up to a 3, so it's 0.563 when rounded properly. So 0.563. Okay, which is slightly higher than the upper limit of the previous interval. Really quickly, before I answer the this part of the question, all right, let me just write an interpretation for the 90% confidence interval. Okay, so with 90% confidence, we can say that the proportion of adults who made a New Year's resolution is between 0.526 and 0.559. All right, and you can convert these decimals into percentages because remember, these are proportions. All right, and sometimes percentages make more sense than the decimals. Right, so between 52.6% and 55.9%, all right, made a New Year's resolution with 90% confidence. Okay, so to answer the question with the given confidence, it can be said that the population proportion of adults who say they have made a New Year's resolution is between the endpoints, of our confidence interval. And lastly, the 95% confidence interval is definitely wider